Hi guys, welcome to lesson 4, and we're going to be talking about complex fractions. So a complex fraction is a fraction within a fraction. So that's what we're going to be dealing with today. So these are the steps that will help you deal with this. So the first thing is we're going to focus on each little fraction. So let me show you an example of this. So I'm not looking at it as this whole thing. I'm looking at it as this, doing what I can here and doing what I can here, and then going to the whole thing. So that's that process. So all of these things in here, these are just things that we would do with a regular fraction. And then finally, we're going to treat it as a whole fraction and then reduce it. So there's lots of like little steps here to take as we go through this process. So the first thing I'm going to do is just focus on this. So remember, when you're adding or subtracting, you have to have a common denominator. So our common denominator is going to be 6. So what do I need to multiply this by to boost it up to 6? Well, I need to multiply it by 3. So I'm going to multiply this by 3. Same thing with this. I'm going to multiply it by 2. So I'm going to multiply this by 2. So both of these now have a common denominator of 6. That's where this is coming in down here. And so I have 3 minus 2. So on top, I have 1/6. So see if you can go through that process and do this down here. Okay, so if you did it correctly, you should have gotten 1/20. So we're still having a complex fraction. So we have 1/6 divided by 1/20. But remember what I said, when you divide by a fraction, you multiply by its reciprocal. So let's see this play out here. So I have 1/6 times 20/1. So this goes back up to here. We're going to simplify and then we're going to reduce. So I end up getting 20/6, and 2 goes into both of those. And so I'm going to get 10/3 for my final answer. Okay, so this one is the same concept. It just deals with variables instead of numbers. But we're doing the same thing. So I'm going to focus on this, say, okay, can I simplify that any further? And I can't, because notice we're kind of like here. We're in that same spot. We've combined denominators, and we're good to go. And so really, we're at the part where we're going to say a plus b over b times ab over a minus b. And so at that point, I'm going to, you can either go ahead and multiply across or cancel. And I think I'm going to cancel out these b's, and I don't see anything else that we can cancel. Remember, do not be tempted to do anything like that, because we look at this as parentheses. So these are protected. So my answer is a times a plus b over a minus b. And you can multiply that a through. Some people get stressed out by that. Like, it doesn't matter. You can multiply it through, or you can just keep it like this. Okay, so negative exponents. In this class, we haven't talked about negative exponents all that much yet. Just remember that this negative exponent means that it's not happy where it is. So I'm going to look at this as 1 over w, and this is 1 over y. So let me rewrite this. And then the same thing on bottom, 1 over a plus 1 over b. Ooh, so we've got a lot of messiness here. Okay, so the first thing I'm going to ask myself, just focus on the top, I don't care about the bottom, what's my common denominator? So my common denominator is going to be wy. So this should feel very familiar to this problem right here. We're just going through that same process. So we're going to see what's missing. So if I'm going from w to wy, I need to bump it up by a y. And if I'm going from y to wy, I need to bump it up by a w. So my answer on top is y plus w. Okay, see if you can do the bottom one. Okay, so you should have gotten b plus a over ab. And now I'm going to do this stuff. So I'm asking myself right now, is there anything at all that I can cancel? And there's nothing. So remember, like, these are in parentheses. I can't do anything with these two, so I'm literally going to multiply across. And don't stress out about order or anything like that. And so that is our final answer. Okay, this one is weird because it's whole number. We want to think about it as 4 being 1. So my common denominator is going to be 3 minus x. Same thing with down here in the denominator. My denominator of the denominator is going to be x minus 3. So see what you can do with those two. Okay, on top, I ended up with this. Be careful because this is a minus. So it's minus 12 plus 4x. And then I ended up with this over here. Same thing with the negative. So I'm just going to kind of clean it up. So I have 4x minus 10 over 3 minus x. And then divided by, let's see, 4 minus x over x minus 3. So be careful, like that kind of gets crazy. So just try to see like this divided by this. So I'm going to flip it and multiply times x minus 3 over 4 minus x. Okay, the next thing that's popping out at me is that these are opposites of each other. So instead of canceling out to 1, that's going to cancel out to negative 1. And then there's really nothing that I can do over here. So I'm just going to multiply this negative 1 here. So I have negative 4x plus 10 over 4 minus x. And it doesn't matter where you put that negative 1. So I could have put it down here and changed these signs down here. So that's just kind of up to you. And that is it for that problem. Okay, so I believe we have 2 more. And this is more of the same. So while this one used numbers, this is going to be the same and using variables. So see what you can do there. Okay, so you should have ended up with this for your second step. And a couple of different things are jumping out at me. Actually, 3 different things. So the first one is this is one of those perfect square trinomials. So if I factored that, it would look like that. So that's kind of jumping out at me. The next thing, this one, I noticed that these 4's cancel out. So I'm left with x squared minus 4. So that's going to be kind of interesting. And then the last thing that I noticed, I'll do this in a different color, these 4's, when I flip them, the x plus 4, sorry, they are going to cancel out as well. So let me show you what's going on. So I'm going to go ahead and just write this out. And then now I'm flipping the next one. So when I factor out that x squared minus 4, I get x minus 2 times x plus 2. Okay, so now once I've done that, a lot of things are going to start canceling out. So this whole yuckiness right here ends up just being x plus 2 over x minus 2. Okay, so this is kind of more of the same. It has, if you'll notice, like a lot of factoring that's going to happen. So see what you can do with that. Okay, so my goodness, there's so much going on here. So this is the first thing that I ended up with in the numerator, and this is what I ended up with in the denominator. Let's just focus on this and just kind of clean that up a little bit. So I end up with 2x squared right here, and then let's add 3x plus an x, so plus 4x, and then plus 5. And on the bottom, I have all of this yuckiness. Okay, so I'm going to go ahead and flip this bottom one. And then on the top, this one isn't too bad. I have 4x minus 6. Okay, now I'm going to cancel. I might look at this. I'm not so sure if I can't factor that. I know that I can factor out a 2 here. So I have 2x, oops, let's try that again. 2 times 2x minus 3. And so I don't know. I'm going to play around with this a little bit more. So you try it too. Okay, so there were so 2 factors of 10 that add to give me 4. There was nothing like that, so I couldn't factor that. So I just started canceling. And so I canceled out these two things. And so I had these three pieces left on bottom. Again, I don't care. You can multiply some of them together. Like it's just, if we broke up everything, it would end up like this. So this is my final answer. And again, you could have a couple different ways to show that denominator. And that is it.